In this video, we will find the possible zeros according to the rational root theorem for this function. Now, according to the rational root theorem, all of the possible rational zeros, well, the numerators, I'm just going to use n for numerator, are always going to come from the constant term. All right, my numerators are going to come from here. And my denominators are always going to come from the leading coefficient. So my denominators are going to come from here. Now when I say come from, what I really mean is they're going to be factors of these numbers. So 1 is a prime number, so it only has one factor, and that's 1. 1 is the only thing that divides evenly into 1. Well, technically 1 is not a prime number, but still, that's the only factor. 2 is a prime number, and it only has two factors, 1 and 2. Those are the only things that divide evenly into 2. And in fact, this line is way too long. Okay, so now, if I want to talk about the possible rational zeros, I'm just going to mix and match these numerators and these denominators. So let's start with a denominator of 1. So I'm going to take this numerator, it's the only one I have, and put it over this denominator. So that would be 1 over 1 is 1. Now I'm going to use a denominator of 2. So I would have 1 over 2, or 1/2. Now I've used up all my denominators, so that's the end of my list. Each of these could be positive or negative, so this is positive or negative 1 and positive or negative 1/2. These are the only possible rational zeros. Now this word rational means there's not going to be like a square root, for example, and there will be no imaginary roots. Okay? So this list is only giving us the non-imaginary, non-radical roots. So let's find a match, plus or minus 1, plus or minus 1/2. So the answer is A. This is the list of possible rational roots according to the rational root theorem.